Hey guys, how's it going? Before getting into anything, I just want to point out that in my first video, I had my mic kind of like down here. And as you can tell, it's not really picking up the audio very well. It's a very dynamic mic, so I need it to be pretty close in front of my face. So sorry if it's covering my chin or whatever. I'm not trying to hide anything, but it's just got to be pretty close to my face for it to really pick up the audio. Shout out to the people who haven't unsubbed yet, even after my Pokemon videos. I just want to make sure that from the very beginning of this channel, I'm doing what I really want to do, so I don't fall into the same trap that many YouTubers have. If you like tech, music, news, and gaming, you're in the right place. Before we get to my actual FFmpeg command, I thought I'd give a little history on why I decided to build a recording PC and the absolute struggle it was to get it working. I've decided to make this a 3-part series. Part 1 will detail the hardware changes, software swaps, and building a mostly functional FFmpeg command. Part 2 will detail the realization that my previously thought to be final command wasn't working like I thought it was, more troubleshooting, and the introduction of a camera to my recording setup. Lastly, Part 3 will detail my final command, explaining how it works and what each individual component does. If you'd like to skip the backstory and get to the functioning FFmpeg examples, click up here to Part 3. However, if you're trying to build your own command and having issues along the way, there may be something in this video that can help you, or just stick around if you like a good story. Also, these won't necessarily be the end of my FFmpeg content. I plan to make a plethora of tutorial videos covering this program. It's an amazing program, not to mention free, and there really isn't much covering it on YouTube. I plan to change that. I'm no professional, and there are certain parts of FFmpeg and its functionality that I don't understand at all. Also, I'm going to be referring to my block of code as a command, and anything that starts with a dash I'll be referring to as a flag. I'm sure this isn't the correct terminology, but I don't know what is. I'm sorry if this annoys you. And guys, if I say anything factually incorrect, please call me out on it, and I'll do my best to correct myself. And as always, if you have any questions or comments on what I'm doing here, please comment in the comment section below. My main monitor when I began this journey was the Asus ROG PG348Q, one of the first high-resolution, high-refresh rate, ultra-wide G-Sync monitors. It had a resolution of 3440 by 1440 and a refresh rate of 100 Hz. For those of you who have experienced 100 FPS plus gameplay, you know it's something really special. Put high-resolution, ultra-wide on top of that, and it provides a gaming experience unlike anything else. With a catch. The default refresh rate was 60 Hz and had to be overclocked to 100 Hz. This seemed pretty strange to me. I had never heard of overclocking a monitor, but it seemingly didn't matter. Remember that, because it comes back to bite me in the butt later. I used to be a fairly happy user of NVIDIA Shadowplay. Quality wasn't the best, it only allowed for 60 FPS capture, audio levels were wonky, and it wasn't always reliable, but for the most part, it worked pretty good. That is until I purchased my first RME audio interface. For whatever reason, Shadowplay and RME software were in constant conflict. I quickly noticed that the FPS overlay was displaying on top of the RME software mixer, and not in my games. I couldn't even get the Shadowplay's menu open with the regular hotkey anymore. I had to access it directly through GeForce Experience. Even once I got into the menu, it didn't matter. None of the hotkeys worked anymore. I couldn't get it to record anything. After uninstalling and reinstalling Windows 10, it started working again. That is, until I installed the RME drivers. It was clear that these drivers were the problem. I spent days trying to fix this, but couldn't figure anything out. There is very little information about these professional audio cards online, and literally no information in regards to my problem. Rather than endlessly contact support from either company, I decided to just try a different program. You've probably heard of it. It's called OBS. While my hopes were high, I quickly ran into another problem. No matter what resolution, FPS, or encoding options I selected, my footage would be jumpy. It definitely wasn't playing back as it should have been. After contacting people on the OBS forum, I found that if I turned off every display except for my main one and disabled G-Sync, I could get smooth footage. They chalked this up to OBS's dislike of displays with varying resolution and refresh rates hooked up to one PC. But what was the point of this setup I worked so hard on if I could only use my main display while gaming? I thought maybe if I did the encoding with a separate video card, I could remedy the issue, so I bought a GTX 1050 Ti for dedicated encoding. Alas, I received the same results, and I couldn't even begin to encode using my i9, as such a high resolution in FPS immediately pegged the processor. A user suggested building a dedicated recording PC with a capture card if I cared that much, and at the time, I wasn't sure I did. But after missing out on several hilarious glitches and awesome plays, I knew what I had to do. I set out to build a recording PC. Wanting to record my display at native resolution and hopefully FPS, my options were extremely limited. In fact, I could only find one capture card advertised to be capable of FPS above 60 and resolutions up to 4K, the Magewell Pro Capture HDMI 4K Plus. I got a 6800K to accommodate the PCI lanes to run a video card and the capture card with no throttling, 32GB of RAM, and pulled the previously purchased 1050 Ti out of my main PC to run in this one. The reason I went with 32GB of RAM was because I plan to utilize OBS's replay buffer feature, which functions a lot like Shadowplay, as in you just press a map top key to save the previous X amount of footage. However, unlike Shadowplay, this footage is cached in the RAM, so I would need a fair bit of it to store any reasonable amount of gameplay. After putting the PC together, I used an HDMI cable to link my main PC's graphics card to the capture card in the recording PC, and then duplicated the display within Windows. Unfortunately, I could instantly tell that something was wrong based on the OBS preview. Not only was my footage jumpy like before, but now my footage had tons of screen tears too. My first thought was that I must have received a defective capture card, or maybe I didn't set it up correctly. I searched for everything and anything about this capture card on YouTube and eventually came across what seemed to be the only video from an actual user. Hardware Talk 2017, Magewell HDMI 4K Plus capture card by a channel called Multiboxology. Little did I know that this video was going to put me on a multiple month chase involving a lot of despair, multiple hardware changes / swaps, and eventual success. Had it not been for this video, I would never have got this working, and probably would have just ended up returning the parts I still could and resold what I couldn't. I'm eternally grateful to Mirai and his channel. He even went as far to answer some of my stupid questions in his comments section. Mirai does some high quality videos on WoW and multiboxing. I implore that you check him out. Considerably into the video, he finally addressed what sounded to be the same problem I was having, or at least one of them.
Luckily, I eventually stumbled upon the problem. The problem is actually a limitation in Windows, the operating system. All 7, 8, 8.1, 10, and even still at this point. The limitation is that when you use a VSync signal, it is only sent to the primary display, and it is not given to any other display that you mirror your main display to. It is not given to any of those. So I'm only mirroring to one other. You could technically mirror to another 10 displays if you wanted to, but only the display that is set as primary in Windows, that is set as your main display in the operating system, is going to receive the VSync signal. So obviously my main display, the one that I can see things on, is the main display as per Windows. And it's the one that's receiving the VSync signal. The capture card is not receiving the VSync signal, so it's almost as if the frame rate is just capped at 60. And that's the stuttering that it's seeing.
Not knowing what to do next, he eventually decided to try an HDMI splitter. After going through a couple of them, he found one that actually worked. He successfully recorded 4K 60 FPS footage with no screen tears or jitters in sight, and it looked great. Great news! This was it. This was the answer to my struggles, right? Unfortunately, not quite. While my display had an HDMI port, it was only an HDMI 1.4 port, which isn't capable of driving my screen at the max resolution and refresh rate. So I needed to use the DisplayPort 1.2 connection, not the HDMI one. I couldn't just get the same splitter he did. This was pretty annoying, considering I almost had a guarantee that the one that he bought would work, and I didn't even know if there were DisplayPort splitters out there. At first, I could only find a cheap one, and after receiving it, I faced a similar problem that Mirai did. Although advertised to support the resolution, it couldn't. Max was some janky resolution between 1080p and mine. Here I was at a seemingly insurmountable roadblock, and I couldn't find anyone that sold a true DisplayPort splitter that supported my resolution and hertz, until one day I finally did. I'm not sure exactly what I searched and why I couldn't find it before, but I came across the VS192x10. This splitter was advertised as a DisplayPort extender or splitter with a maximum resolution of 4K at 60 Hz. 4K at 60 FPS has a slightly higher bandwidth requirement than 3440 by 1440 at 100 FPS, so theoretically, this should work perfectly. Unlike the first splitter I tried, it wasn't cheap, and considering they had a market dominance on DisplayPort splitters, I wasn't surprised. Luckily, I found it for a bit cheaper than other sites on a website called ProVantage. However, if you're looking to pick one of these up, they no longer sell them. B&H Photo is one of the few places that still sells them if you want one, but it's a special order item and can take 3 to 4 weeks to ship. After receiving it a few days later, I was ecstatic to give it a try, left work early, and got it hooked up. And just to quickly mention, I'm using a pluggable active DisplayPort to HDMI 2.0 adapter to get the splitter to work with the capture card, which only has an HDMI input. You may be asking, well Gabe, why couldn't you have just gotten the same splitter as Mirai and just used adapters to convert the HDMI to DisplayPort? Well, that's because an active HDMI 2.0 to DisplayPort 1.2 adapter doesn't exist, or at least it didn't at the time. The adapter I purchased along with any other DisplayPort 1.2 to HDMI 2.0 adapter on the market only works in one direction, DisplayPort to HDMI, not HDMI to DisplayPort. I started recording on my desktop and the screen tears were gone, but came back after launching any game, not only in the footage but also on my main display. This was new and problematic behavior. Not to mention that the stuttering I mentioned earlier when using OBS to record my main PC was still present. At this point, I was pretty frustrated. Not only had I accomplished nothing, but my recordings looked even worse than before. I found that the stutters harkened back to my post on the OBS forum and the answers I received. Even when using a capture card, OBS was still struggling with multiple resolutions and refresh rates being handled on one PC. The display I was using to monitor OBS was 1080p at 60 Hz, but the footage I was trying to capture was 3440 by 1440 at 100 FPS. You really wouldn't think this would be an issue, but unfortunately it was. This didn't seem like something I could get around using OBS unless maybe, just maybe, I bought another PG348Q to use on the recording PC so everything matched up. But I wasn't sure this would work, and another one of these monitors was going to cost me $1,300. I just really didn't want to buy another one, nor did I know where to put it. I'm running out of space on this wall, and there's no way it was going to fit in the same place as the other one. Brainstorming on what to do next, I remembered Mirai mentioned something about switching from OBS to another program, FFmpeg. When I heard him talk about FFmpeg for the first time, I didn't care enough to check it out. I wanted to stick with OBS. It had the replay buffer feature which I really wanted to keep, but left with little to no other choices, I went to go take a look. I was faced with instant intimidation. This was no conventional program, more like a programming language. Obviously, it's not that quite extreme, but it's the best example I can think of. It has no GUI and everything is done in command prompt with literally hundreds of functions and filters with pages upon pages of documentation. I had no idea where to begin, so I started Googling tutorials, finding little to no video tutorials and some extremely confusing text tutorials and forum posts. Eventually, I was able to stumble my way to my first functional command, which heated actual video output with the desired resolution and FPS. Stutters that I would get in OBS were finally gone. Gameplay looked really smooth in that aspect. Unfortunately, I was still getting the previously mentioned screen tears. They only occurred once I launched the game, and the tears could be seen on my monitor and in the recording footage. Desktop footage looked perfectly fine. What on earth could be causing this? I enabled the FPS counter in Steam and launched Rocket League. Strange. Even though VSync was enabled, my FPS was exceeding my monitor's refresh rate. At first, I thought this must be the switch from a 10, but support assured me that the switch was capable of 3440 by 1440 at 100 FPS. I was stumped once again. Around a week after troubleshooting, I remembered something. This monitor had to be overclocked from 60 Hz to 100 Hz. Sure enough, after downclocking the display back to its native 60 Hz refresh rate, no screen tears. Footage looked fine, the display looked fine, but at a huge cost of 40 FPS. And as I mentioned before, once you game at a high refresh rate, there's no going back. While I couldn't guarantee that the problem was with the overclock and not just a problem with recording 100 FPS in general, I felt almost sure that it was. At this point, the only choice I had was purchasing a new display. I really wanted the size, resolution, and refresh rate to be exactly the same, but without the need for overclocking. With a stroke of good luck, Asus had been working on a new display, the Asus ROG Strix XG35VQ, only a few weeks out from release. This was almost identical to my monitor, except it didn't have G-Sync, but if you remember, I already had to disable that. If you didn't already know, G-Sync only kicks in if your FPS dips below your monitor's max refresh rate. With my high-end PC, this only happened in the most demanding of games at the max settings. G-Sync just wasn't as important to me as it was when I had two GTX 780s. Also, this monitor had a few improvements from mine. The screen was 1 inch larger, it had better color accuracy, it got brighter, and I would argue the bezel even looked better. Last but not least, according to the documentation, it ran at a native 3440 by 1440 at 100 FPS, no overclocking required. The screen cost around $800, which is actually really cheap for what you're getting in my opinion, and I was able to sell my old display on eBay for the same price. Things worked out perfectly. A few weeks passed and I finally got my display. which I instantly had to return due to a dead pixel. Fortunately, I got another one in just a few days later, no dead pixels in sight. Hooked it up to the Switch, did some recording, and I could hardly believe my eyes. No screen tears, no jitters. Buttery smooth 3440 by 1440 100 FPS footage and gameplay. The footage was at such a high quality that when played back on the same display, I honestly wouldn't be able to tell if it was a recording or the actual game playing. But if you've learned anything by now, you should know this isn't the end of the story. I found that while recording every once in a while, I would drop a frame, and sometimes I would drop a ton of frames over the course of a few seconds. While I could maybe look past this, it wasn't the only issue. When I dropped frames, the audio didn't do the same. Basically, as I dropped frames, the audio link to the clip would slowly become out of sync. After another few weeks of troubleshooting, I found that if I replaced the -R flag with -framerate when a frame was dropped, FFmpeg would just duplicate the last recorded frame so the audio wouldn't go out of sync. Problem was that when I replaced the -R flag with -framerate, I was getting a new warning message: past duration too large. It was spamming in my console 20 times a second. As soon as I received this warning message, my export file would become corrupt with nothing to play back. When I searched the warning online, there really wasn't a definitive answer on what it meant, and the solution given to fix the warning was to change the framerate flag to -R, which I knew by now only created other problems for me. I searched and searched for any solutions I could find, but nothing came up. As soon as I was going to give in and just deal with out-of-sync audio that I would have to realign in post, I figured it out. For no reason at all, and what I can only explain as an act of God, I decided to change the input frame rate in FFmpeg from 100 to 200. The warning message was no longer spamming in my console, and my audio never went out of sync. I have absolutely no explanation for why this worked, and no one online seems to know either. Answers would be nice, but honestly, I just don't care. I had solved yet another problem which haunted me for weeks. Meanwhile, I was still dropping frames, and like I said before, sometimes it would be a ton over the course of a few seconds or just 1 to 2 every so often. With -framerate simply duplicating frames to keep the audio in sync, this didn't bug me enough to look for a fix. Until I dropped a ton of frames during something I really wanted to keep. The clip was basically unwatchable. I had to fix this issue. While I found solutions to other people dropping frames, none of them worked in my case. As a last-ditch effort, I decided to download the latest nightly build of FFmpeg, and it didn't seem to fix my issue. But once again, with a stroke of good luck, a solution found its way to me. I was getting a new warning message: thread queue size too small, please increase. I was annoyed. Why wasn't this warning appearing before? It seems like any time I try to fix something, I just create more issues. But little did I know, this was actually the solution to my problem. Unlike many other things in the documentation, thread queue size seemed pretty straightforward. The value represented the maximum number of packets which you could keep in queue, and according to the warning, I had mine set to the default value of 8, which seemed pretty low. I added it to my command and incremented the value until the warning stopped popping up, and just like that, I never dropped a frame again. So at this point, by all means, I had a perfectly functional command, which was amazing. But the way it was currently set up, it would just continually record to one file. This was a problem because if I had a long weekend gaming session, I'd easily fill up my entire hard drive. 3440 by 1440 at 100 FPS gameplay doesn't make for a small file. I was over a gigabyte per minute. Back to the FFmpeg documentation. Unlike many other times, I quickly found a fairly straightforward segment function. This allows you to dictate the amount of time you want before your file splits and how many segments you want your file to split into before looping back to the first file. I decided to go with 9 parts, 10 minutes each. This gave me the last hour and a half of gameplay at any given time in convenient little parts. This is similar to Shadowplay and OBS's replay buffer feature, but in my opinion, it's even better. Rather than having up to the last 20 minutes of gameplay with the press of a hotkey in Shadowplay, I had 4 times as much past footage at any given time with no need to press anything. Also, if I were to blue screen or lose power, the most footage I could lose was less than 10 minutes. When I wanted to add commentary, I recorded my mic and Discord straight into Adobe Audition as 2 giant files that I had to line up to the gameplay later. I ran with this setup for a while. It was more than anything I had hoped for coming into this project. It wasn't until I was lining up my voice in Discord and the gameplay footage, having trouble finding exactly where each file needed to be, when it occurred to me. Is there any way I could just get FFmpeg to do this in real time for me? Just to quickly explain, I have 2 RME audio interfaces, the HDSP AIO in my main PC and the Fireface UC hooked up to my recording PC. I originally bought these cards for music production, but it just so turns out that they're absolutely amazing for linking audio between 2 PCs. I can share up to 16 channels between the interfaces via ADAT carried on an optical audio cable. They also have this awesome loopback feature that allows you to combine multiple outputs or inputs to one input channel. This allows me, for instance, to send both my mic and my soundboard into Discord, despite Discord only allowing one audio input. I plan on covering my audio setup in much more detail in its own video after I finish this series, so get subscribed if you'd like to see that. During my quest to build my initial FFmpeg command, I noticed a lot of people exporting video and audio as separate files for one reason or another. I thought that maybe if I added these audio channels as separate inputs and outputs and then split them just like I split gameplay footage, everything would just be in sync. I was getting 3 different groups of files as intended, but 2 of the groups meant to contain voice and Discord simply contained the gameplay audio. This is because I didn't have the channels mapped properly, and it didn't take me long to find this out after searching for a solution. All I had to do was use the -map flag with different identifiers for each stream. This applies to audio streams and video streams. From what I understand, the number before the colon represents the input file or device, and the number after the colon represents individual streams of said input. Sure enough, I was getting 3 groups of output files, each group was being parted, and each part contained the desired content. However, after dragging them into Adobe Premiere, I found that they didn't start at the same time.
Play, pause, play,
Points of
pause, play,
error,
pause, play,
rather than
pause,
having to focus.
play, pause,
Almost
play,
used all
pause, play,
5.
pause.
Basically, it takes time to initialize each output. My voice file would start up almost instantly, followed by the Discord, and then my video stream. It's just a limitation of FFmpeg currently. You can't output to multiple files using multiple audio channels and easily keep them in sync. In theory, it's a pretty simple fix. I just need to add delay or silence at the first of the file containing my voice and the second file containing the Discord. So when played back, they'd start at the same time as the video stream. I thought that maybe the -its offset flag would be the solution, but I soon found out it only worked on video streams. I went weeks without finding a solution to this. Nothing really came up when looking for delay audio FFmpeg online. Every time I've thought of giving up, I eventually found a solution. At this point, I knew the drill and I wasn't going to stop until I found one. And eventually I did. I can't remember exactly what I searched, but I came across a forum post with someone talking about FFmpeg filters. What are filters? Why haven't I heard of them up to this point? Sure enough, right there on the FFmpeg documentation page, there was a section titled Filters. And boy, oh boy, was there a lot of them. Even more functions here than in the normal documentation. I did a Control F in Chrome with the term delay and eventually found the A delay filter, which sounded just like what I needed. Basically, it lets you delay individual audio channels, filling the new samples with silence. This is important because I don't necessarily want to delay the initialization of the device, but actually have delay embedded in the output file. Each channel of audio in the filter needed to be separated by a bar, so for a stereo stream, you would use one bar, as a stereo signal only has 2 channels. By placing -AF, which allows you to apply audio filters, and then the filter here before the output file, I got it to work. I was actually delaying the audio in the output file. After much trial and error, I was able to tune the filter to the exact milliseconds I needed to perfectly line my mic and Discord up to the video stream. Sweet success. It works. It actually works.
Play,
on the
pause, play,
whole loop
pause, play,
and the
pause. Play,
and it only
pause, play,
takes about
pause, play,
1 point,
pause.
or at least I thought it did, but we'll come back to that in a second. While I record with my other PC, I use my Surface Book to edit and compress parts without ending the recording. Let's say I'm playing Rocket League and get a nice goal. Sweet, I want to hang on to that for later. First, I have to wait for the part containing the desired footage to close off. Then I slightly modify one of these commands to reflect what part I want to cut and compress, where I want it to start, and how long I want it to be. This applies to both audio and video if I plan to add commentary to these clips later. Utilizing Logitech Flow, I copy and paste the command into the terminal on my Surface Book and let it do its thing. My Surface Book isn't the most powerful computer out there, but it has about an hour and 20 minutes to finish before FFmpeg cycles through all the other parts to overwrite the one the Surface is reading from. The best part about all of this is I just continue to play while these processes take place. Sure, I have to jump away from the game for a second to edit some of these commands, but that's easy to do between matches, dungeons, or whatever. If for whatever reason I really don't have time to modify one of these commands, or I'm trying to save a large chunk of video or audio, I simply drag the part I want to keep into the temp folder to deal with later. And of course, if my intent was to record a playthrough of some sort, I could easily omit the parting flag to record one long clip. However, I would probably still leave it in and just increase the amount of parts to a number I'd never reach. This way, I still have the security involved with parting files, only ever losing up to 10 minutes of content in the event of a blue screen or a failure of some sort. I also went ahead and made similar commands for recording my Switch and PS4 Pro. I record both consoles at their native resolution, 4K for the PS4 Pro using another splitter from a 10, and the Switch at 1080p with a really cheap splitter from Amazon. I use HDMI switches on the inside of the skirts of my table to route the PC, PS4, or Switch to the capture card. However, I will say that when switching between the devices, the capture card sometimes spits out incompatible signal, and I have to reboot the computer. This is a little unfortunate, as if I were to be streaming, for instance, and wanted to play another game in between matchmaking or something, I couldn't. But that hasn't really been a problem for me yet, as I don't really stream. And speaking of streaming, to take this one step further, you'd probably want to incorporate some sort of webcam or DSLR with another capture card, which is actually what I ended up doing and how I'm recording this video right now. I didn't plan on incorporating a camera directly into my setup until after I had recorded and uploaded this video, but the parts came earlier than expected and troubleshooting began. While trying to incorporate the camera, I found my command actually wasn't working as I expected. When recording for extended amounts of time, my gameplay and its audio would slowly desynchronize from my commentary. Surprise, surprise, but we'll discuss that in the next part. No need to make this video any longer than it already is. Part 2 and 3 should be significantly shorter than this one, and as mentioned before, if you don't care as much about the details, feel free to skip to Part 3, which has my final command and examples. In Part 2, we will discuss the struggles of incorporating a camera into an already confusing setup, and the discovery that my command wasn't working quite as I intended. Thanks for watching, and I'll see you guys in the next video.